Firstly, what is bullwhip effect? The bullwhip effect is an observed phenomenon in forecast-driven distribution channels. It refers to larger and larger swing in inventory in response to changes in customer demand, as one looks at firms further back in the supply chain of the product. The concept first appeared in J. Forrester Industrial Dynamics, 1961, and thus it is also known as the Forrester effect. Since the oscillating demand magnification upstream of a supply chain is reminiscent of a cracking whip, it became known as the bullwhip effect. Bullwhip effect and supply chain. A supply chain involves a series of steps involved to get a product or service to the customer. For a manufacturer to get the right product to customers on time, both information and product must flow well between manufacturer, distributors and retailers. To anticipate customer purchases, retailers, distributors and manufacturers each make their own forecasts of demand, adjusting them to cover spikes in demand and to take advantage of economies of scale. This causes inefficiencies in the supply chain. For example, in the mid-90s, Volvo found itself overstocked with green cars in the middle of the year. The company offered attractive pricing deals to clear them out of dealerships. Green Volvos started to sell, but nobody told manufacturing about the sales promotion. Manufacturing noticed the increase in sales, and decided to ramp up production to make more green Volvos. At the end of the year, Volvo was left with a large inventory of unsold green cars. Such is the influence of bullwhip effect on the supply chain. Let's try to understand bullwhip effect by this scenario. For example, if customers' forecast demand is 10. The retailer would replenish his supply by actually ordering 15 items from the distributor, where the additional 5 items were used as safety stock to ensure he wouldn't run out. The distributor projected demand based on the retailer's order of 15 items and then placed an order to the manufacturer for 20 items to take advantage of buying in bulk for a better price. Next, the manufacturer increased the order to 40 items because it cost less per item, on average, if more items are produced. Because the replenishment orders didn't reflect immediate needs, extra items were produced, and they sat in storehouses. This inventory cost companies to store and tied up capital that could have been used to produce other items for sale. As fear mounted around COVID-19, we witnessed people, who usually used to buy 10 rolls of toilet paper at a time, buying 100 rolls of toilet paper. This stocking up sent signals of false demand caused longest global delivery times while manufacturers, distributors and retailers were struggling to keep up with stockouts and rising demand. This also sentenced factory workers, truck drivers and retail store associates to hours and hours of overtime in the middle of a healthcare crisis. Some of the major causes of bullwhip effect includes demand and forecast updating, order batching, rationing and gaming, price fluctuations. Let's study each causes in more details. First, demand forecast updating. Every company in a supply chain follows product forecasting, which is usually based on the past order history. Demand forecast updating is done individually by all members of a supply chain. Each member updates its own demand forecast based on orders received from its downstream customer. The more members in the chain, the less these forecast updates reflect actual end customer demand. Second, order batching. Order batching occurs when each member takes order quantities it receives from its downstream customer and rounds up or down to suit production constraints such as equipment setup times or truckload quantities. The more members who conduct such rounding of order quantities, the more distortion occurs of the original quantities that were demanded. Third, price fluctuations. Price fluctuations due to inflationary factors, quantity discounts, or sales tend to encourage customers to buy larger quantities than they require. This behavior tends to add variability to quantities ordered and uncertainty to forecasts. Fourth, rationing and gaming. Rationing and gaming is when a seller attempts to limit order quantities by delivering only a percentage of the order placed by the buyer. The buyer, knowing that the seller is delivering only a fraction of the order placed, attempts to game the system by making an upward adjustment to the order quantity. Rationing and gaming create distortions in the ordering information that is being received by the supply chain. The bullwhip effect has several negative consequences. First is stockout. It leads to stockouts when companies overcompensate for the past inventory excess on future inventory orders or if customer demand jumps. Second is waste. The company may order extra inventory to protect against future occurrences of product shortages. Third is change in buying patterns. When companies experience the bullwhip effect consistently and in extremes, they may consider changing buying or ordering processes, shifting away from batch ordering or increasing the ordering frequency. Fourth is tense supplier relationships. The bullwhip effect can cause company buyers to put pressure on suppliers, which may lead to tense relationships. If you constantly have faulty demand forecasting, suppliers can become frustrated with buying back excess inventory or urgent demands. So, how can we avoid the bullwhip effect? Taking note of suppliers' inventory of whether it's stocked up or stock out and adapt to the forecasted customer demand for it appropriately. Making sure everyone in the supply chain is known of the forecasted demand is helpful to prepare accordingly, having an idea of stock and safety inventory at every stage. On the other side, communicating with the customer regularly so the forecasts are up to date. Cutting down lead time and delays are surely helpful as the system is able to adapt to demand changes faster without any delay. Reducing delivery by half is known to reduce bullwhip effect by 80%. Adopt demand-driven supply chain management. We know that forecasts are inaccurate, and when demand is more than predicted, emergency orders are placed, which causes the supply chain to go haywire. In contrast, adopting demand-driven supply chain is known to be more agile and adapt to changes faster, as can be seen in the shown chart, which mainly involves real-time information transfer. Certain products have high minimum order quantity for end customers, resulting in overall high gaps between subsequent orders. Lowering the minimum order quantity to an optimal level will create smoother order patterns. Stable pricing throughout the year instead of frequent promotional offers and discounts may also create stable and predictable demand. In contrast, the system can indeed prepare for offers and discounts by using historical data to get benefits from festivals.